What we're going to do is we're going to look at why, like, there are some poker hands that are worth more than other poker hands, and it's obvious. You could, if you had two pairs, it might make sense to say, hey, that is obviously better than one pair, because I have two of something and two is better than one. Last time I checked, when I had $2, that was better than when I had $1. So here we have two pairs, but the question is, when things look differently, like why is it that two pairs is worth less than this hand, where I have three of a kind? Here I have three of a kind and two other ones. Why is that better than this hand where I have two pairs? Because 3 is better than 2, but 2 plus 2 is 4. Oh my goodness, I'm so confused. Okay. Maybe. So we're going to figure out why this hand in poker is considered to be harder to get than this one. Okay? What's that? Okay. So what we're going to do is we're going to count hands. We're going to start off with something simple. We did this already last class. Number one, we're going to figure out, we did this already, how many ways you can get one pair. So one pair in poker, question? You'll have some questions with counting cards. They can come up in different ways. So one pair, for example, would be 2 2s, and then the other 3 cards are different. So we're going to go through 3 examples, sort of explain things, and then summarize the strategy afterwards. If I told you the strategy first, I think you'd be confused by it. So seeing some examples first, and then we talk about the strategy, I think will make some sense, and then we'll solve a couple more. So here we go. We're going to have a pair. Well, when counting how many ways you can get a pair, first of all, you need to decide which number is going to be the pair. Am I going to get a pair of 2s, a pair of 8s, a pair of kings? So there's 13 different kinds in the deck, and I need to choose one of them. And I don't say 13 numbers because it's like Jack, Queen, and King. Those aren't really numbers. So we say, in cards, we often call things different kinds. That's why you get 3 of a kind, means 3 5s or 3 9s or 3 kings, and so on. So 13 choose one is picking which kind of card that I'm going to get a pair in. But if I choose the 2s, how many 2s are in a deck? 4. And I could get a pair of 2s by having 2 of hearts and 2 of clubs, or 2 of hearts and 2 of diamonds, or 2 of clubs and 2 of spades. So after I've chosen what kind of card is going to be my pair, I then need to choose which 2 of those cards I'm going to have. So what I'm going to do, I want this to be blue. There we go. That's not blue. That's blue. And I'm going to underline the 2 2s in green because that's what I did here. And I picked a pair here. And in fact, 13 choose 1 times 4 choose 2 counts every single pair possible in the whole deck. Because I have every kind and of that kind, which specific cards I'm going to pick. Sometimes people call this part suits. I like to just think of having all 4 cards and deciding which 2 I'm going to pick. So here, when I pick my kind, if I pick 2s, I don't know which 2s I have. So I have 4 2s, then I pick which specific cards next. After that, one of the strategies we're going to have is when we have cards of the same size or groups of the same size, we have to choose them at the same time. So here I have 3 single cards. I need to choose from the 12 remaining kinds, because I can't choose a 2, because I've already used that. Of the 12 remaining kinds, I need to choose 3 more. In this example, I chose the 3, the 6, and the 9. How many 3s are in the deck? 4. And I just need to choose one of them. How many 6s in the deck? 4. I need to choose one of them. How many 9s in the deck? 4. I need to choose one of them. All of this picks 3 single cards. Yes. Well, if I have already chosen a pair, if I've already chosen the 2s, I can't have another 2 here, because then I wouldn't have a pair anymore. I'd have 3 of a kind. So there are 12 kinds left. And I need to choose 3 of them for my single cards. So in our example, the 3 that I chose are the 3, the 6, and the 9. And choosing a 3 and a 6 and a 9 is not different than choosing a 6, a 3, and a 9, or a 9, a 3, and a 6. So I have to choose them all at the same time because I don't want order. Because in a poker hand, there's no order. And notice between the green part and the red part that there's no overlap. Here I'm choosing a pair, and over here I'm choosing different numbers to go with that pair. I'm not choosing another of the same kind in there. That's why it's 12 choose 3, because one number is taken out. Okay? Yes. No, this is just my explanation. To say that that in the red line is 3 single cards. Yes. The 4C2 in the green part is after I choose which kind I'm going to pick. Let's say I choose 2s or I choose 5s. There's 4 2s in the deck. 2 of clubs, 2 of hearts, 2 of diamonds, 2 of spades. I need to choose which 2 of those 2s I'm going to have. So that's where the 4 choose 2. It's like picking which suits, but it's picking which specific cards. Yes. The 12 choose 3 picks which numbers or which kinds I'm going to have. And then after that, since I picked 3s, there's 4 3s. Which numbers after the? 2, 2, 3, 6, 9. It's predicting, I'm predicting 3, 6, and 9. It could have been 5, 10, and jack. Whichever 3 kinds you pick, if you pick 3, there's 4 3s in the deck. Which specific ones? So these ones are which specific card you will choose. Yes?
Can we ask for card packs on the listing this?
Like how many cards are in a deck and how many of each one? Yes. Okay. I can even give you a deck of cards if you'd like. Okay. Again, what we'll do is we're going to look at a couple of these, and some of your questions that you're having, which are great questions, you'll see some patterns come out. So we'll do another one, and then we can ask some questions. So the next one we're going to look at is how many poker hands have 2 pairs. So an example of that is the one that I showed you right here, is getting 2 8s, 2 9s, and a 7. So that's 2 pairs, and the third card is something different. So the first thing we're going to do is we're going to choose our pairs, and I'll underline them in green because they're the same size. You have to choose them at the same time. 13 choose 2 chooses which kinds of numbers I'm going to have for pairs. If I chose 8s and 9s, there's 4 8s. I need to choose which 2 I'm going to take. There's 4 9s. I need to choose which 2. All of this together I'll underline in green because it matches with that 8 8 and that 9 9. This will give us our 2 pairs. What do we have left to count? 1 single card. How many numbers are left? How many kinds are left? Because I can't choose an 8 or a 9. I have 11 left. I need to choose one of those. And once I've chosen the kind, 4 choose 1. And this will give me a single card. Now, some would argue, couldn't I just do that all at once by doing 44 choose 1? Because after I take out my 8s and 9s, there's 8 cards in total in the deck. If I take 8 away from 52, I'd have 44 cards left. Couldn't I just do 44, choose one? Yes. But I want to stay with this style where we pick the kind and then we pick the specific card. But it is true. What is 11 choose 1? It's 11. And 4 choose 1? 4. And 4 times 11? 44. Same as 44 choose 1. Yes.
Does that work like every time, or does it automatically have to be one?
That this, when these are ones, this will work. Only if it's ones. Yeah, if you have 11 choose 2 and 4 choose 2, it doesn't make 44 choose 2. One more. We'll do our 3 of a kind. Oh, be nice to have some numbers here. Let's actually figure these out. What is happening with this? Blah. Let's actually write down these numbers. So let's go to our calculator. 13 choose 1 times 4 choose 2 times 12 choose 3. The first one, there are 1,098,240 hands that have a pair. That's quite a few. Oh, this is off. Dun, 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 dun. Okay. Look, it works. Good. So now a second one. Has anyone figured it out already for me? No. 123,000. Sorry, what was the last 3 numbers? 552. So about 5 times more likely to get a pair than it is to get 2 pairs. Now the question we originally started with was, what's more likely, 3 of a kind or 2 pairs? We can compare that. So now to figure out 3 of a kind, and an example of 3 of a kind is what I had here, which was 3 kings, a queen, and an 8. So you have 3 of one kind and the other 2 are different. So first of all, we need to choose our 3 of a kind. 13 choose 1. That would give you all the choices of what kind you're going to pick. If you chose kings, there's 4 kings in the deck, and you need to choose 3 of them. So I can underline this, and this is our 3 of a kind. We then need to get 2 single numbers. Those groups are the same size. We have 12 left, 12 kinds left. We need to choose 2 of them. And then for choose 1, choose which specific cards for each of those 2 kinds. If you're doing single cards, yes. If you're doing triplets, you need 4 choose 3. Pairs will be 4 choose 2. Well, because this is 2 single cards. Because you're picking single cards, then you only choose 1 of them. Yes? By kinds, I mean ace, 2, 3, 4, 5. And the reason we say kind is because there's jack, queens, and kings. So if they were all numbers, you'd say choose your number first, and then choose which suit goes with that number. In some games there are. Sometimes they're 11, 12, 13, because that's the next number. But you would never go, ha-ha, 3 13s in a poker game. You would say 3 kings. And that's why in poker it's called 3 of a kind, not 3 of a number.
So you win by having the one that's
Least likely, right? Because if you have something that's least likely, that's better, right? It's like the lottery. I can buy a lottery ticket and I could not win. That's very likely. And when I don't win and I go there, they give me no money, right? If I get the least likely thing, which is winning, then they give me lots of money. But they don't give lots of money to lots of people because that's not very likely.
So like, sounds like it's like a television. Sometimes they'll have like the odds of like the card they have.
Right.
So like they do.
They're figuring out this mathematics as they go along.
And then they do that over like 2.6 million difference.
They find the difference, but they're also looking at, they're giving you statistics along the way. Given what they already see, what are the chances that person's going to win?
So is it like, I'm pretty sure it's like computerized.
It is computerized, but what they're looking at the beginning is they see all the information. So all they have to do is figure out, if there's 1 card left to have and there's only 40 cards left, you would win on 10 of the cards and I would win on 30 of the cards. So that would mean 30 out of the 40 I win, so I have a 75% chance. 10 out of 40 you would win, you would have a 25% chance. And that's the kind of math they're doing. They're looking at what's left, looking at all the possibilities of what could happen, and who would win and who wouldn't.
how is a real flush player if it doesn't have any
Well, there's only 4 royal flushes in total, whereas 2 pairs, there's 123,000. And if we multiply this through, has anyone done this already? $13 times 4. Only 54,912. So now we can see why it is that 3 of a kind beats 2 pair. It's less likely to get. Yes?
Is that number, is that like these 54,000 combination or possibilities of that out of the
Out of the 2.6 million ones in total.
also how come for the 2 pairs you did 11 C1 but like the second one is 12?
So on the 2 pairs, I did 11 C1 because in the green underline, I already chose 2 numbers, or 2 kinds. 2 kinds are already gone. Okay? So there were 13 kinds. I chose 2 of them. The last single card here has to be different, and there's only 11 kinds left to choose from. Whereas in this one, the first thing I did in green, I only chose 1 kind, leaving 12 kinds left. Okay? So at this point, we're going to sort of put a summary. A summary of some of the strategies that we've done up till now. First thing, I'll say we choose groups of kinds of the same size at the same time. So if we look back at what I underlined in green and what I underlined in red, right? Here I have 2 single cards. I choose those at the same time. In number 2, I had 2 pairs. So that group is, they're pairs. There's 2 in each one. So I have to choose them at the same time. And the reason we have to do that is because if we chose them separately, if I chose 1 pair first and then another pair second, there's going to be overlap because it would allow me to pick 8s first and then 9s, and it would count 9s first and then 8s as something different. But in cards, the order doesn't matter, so the same size has to be chosen at the same time. In the first one, we had 3 single cards, all of this, that's groups of the same size, I had to choose those all at the same time. And the reason we do 3 examples first before we write a summary is because if I would have written this down at the beginning, you would have no idea what I was talking about, right? But Mr. JR, I still have no idea what you're talking about. Okay, well, hopefully after we write this and then do a couple more, maybe that goes away. So 1, choose groups of kinds of the same size at the same time. And then 2, what did we do? We chose, I'll put that, the kind first, right? This has nothing to do with being nice. Math is not kind, right? Okay. Choose the kind first, and then the specific cards. So that's what we did every single time. We chose which kind, and then of the specific cards, of the 4 of that kind, how many are we going to choose? Those are our strategies for this type of poker hand. Now, we're not going to count all of the poker hands today. We're not going to count straights. We're not going to count flushes. But those would have strategies as well. So if we chose, 4th one, 5 different cards. And for this one, I am going to put an asterisk beside it because we are going to include in this 5 different cards that might be a flush, 5 different cards that might be a straight, and which would also include straight flushes and a royal flush and stuff like that. Straight is when you go like 4, 5, 6, 7, 8. 5 cards in a row. But we're just going to do 5 different cards. The way that you would actually count this is you would start this and use a not strategy and then have to count out your flushes and subtract them, count out your straights and subtract them. The order doesn't matter. So 5 different cards. Well, an example of that would be 2, 5, 6, 8, and king. 5 different cards. They're all the same size. So you would choose them all at the same time. 13, choose 5. Then for each one, 4, choose 1, 4, choose 1, 4, choose 1, 4, choose 1, 4, choose 1. Figure out how many this is with our calculator. 1,317,888. So by far the most likely thing, but not too far off of a single pair, right? It's not that much worse than a single pair. But both a pair and 5 different cards together, if you added those up, that's 2.3 million of the 2.6 million possibilities. So quite a few. But this 1.3 million also included some flushes and some straights. So there would actually be less than this, but we're not going to worry about counting that right now. In cards, there's a very good hand called a full house. Does anyone know what a full house is? What's in a full house? 3 of one kind and 2 of another kind. Why is this such a good hand? Well, we'll count it to see how many there are, and then it gives you a sense of how unlikely it is. So to get 3 of one kind and 2 of another, this is one size, so I'll choose that first. 13, choose which kind. And then there's, for the 3s, if you happen to choose 3s, before choose 3 of them. That will count your 3 of a kind. And then we need to choose our 8s, or any pair to go with are 3 of a kind. So now there's 12 kinds left. We need to choose one of them. And there's 4 of those specific cards. Choose 2 of them. And that will count your pair. And there are only 3,744 full houses. Now, because some of these higher up ones are very unlikely, right? If you do this over 2.6 million, your percentage is like really, really low. So most poker games aren't just here's 5 cards, what are we going to have? Because it's not going to be, because almost every single hand will be, I have nothing, I have nothing. Okay, then we'll play another one. I have nothing, I have a pair, okay. You never get any of the exciting hands. So most poker games have something that allows you to play longer so you get chances at these extremely rare hands. Like in Texas Hold'em, you get your 2 cards plus 5 more and you make your best 5 cards out of the 7 that are there, which increases your odds of getting something really good.
That's like poker.
Yeah.
I mean, we're talking about poker so much. Why don't we just gamble?
Why don't we just gamble? Because then I'd probably get fired. Okay.
Yeah, close the door.
Yeah, I'm recording.
What stays
I-
what stays here stays here.
Can gamble marks, right? I started class with a 12%, and by the end of the day, I was in the 80s.
Hopefully
Nice.
people will lose so much marks and be funny as heck.
Double or nothing. 4 of a kind. How rare is it to get 4 of a kind?
It's impossible.
Well, here's our one group. We have to choose which kind we're going to get 4 of a kind. And then the specific ones, you need all 4 of them. I mean, that's a little bit redundant. Choose 4 is 1. But you can put it there. This chooses your 4 of a kind.
Mister.
12 cards left. Choose 1 and then pick your specific card. That will get your single card to go with your 4 of a kind. If we type this into our calculator, only 624. So you have a way better chance of getting a full house than you do a 4 of a kind. And by counting them, we can see why it is in poker there's different levels of why some hands are worth more than others. And if you have a royal flush, there's only 4 of them, because you can get a royal flush in hearts, in spades, in diamonds, and in clubs. And because there's only 4, it becomes the best hand possible.
We don't have to involve money.
Yeah, let's play more.